Welcome students. Today we will take sixth problem on trusses and we will solve this problem through method of joints. So let us start the lecture. So we are given one truss over here and we are asked to find forces in all the members of the truss by using method of joints. We know whenever we have to solve any problem on trusses by using method of joints, then the very first step is we should identify what type of supports are given in the truss. So in this truss we are given two supports. One is a pin support at joint E and the other one is a roller support at joint F. We know pin support provides two types of constraints. It provides one reaction normal to its surface and other reaction acts along its surface. Roller support provides only one reaction which acts at normal to its surface. So let us label these reactions in the next step. So we have labeled normal reaction at pin joint and we have labeled its name as reaction at E in Y direction. And for this reaction we have assumed its direction in upward direction. This is just an assumption right now. Other reaction at this support will act along its surface. So we have shown that reaction along its surface and we have labeled that reaction as reaction at E in X direction. And we have assumed that this reaction is acting towards right. So at roller joint we have shown its normal reaction and we have assumed its direction in our direction and we have named it as reaction at F in Y direction. So first step is identify the supports in the truss. Second step is label the reactions provided by those supports. Now in the next step we will apply equations of equilibrium, that is summation fx is equal to 0, summation fy equal to 0 and summation m equal to 0 in order to find the values of these three unknown reactions. So let us start with the next step. So you have to find Rex, Rey and Rfy. So let us apply the first equation, that is summation f equal to 0. So before applying this equation, let us first see how many forces are acting in this truss. There are 5 forces. 900 Newton force acting at joint A, 900 Newton force acting at joint C, then we have these three reactions. Now out of these 5 forces, 3 forces are there which are acting in X direction. So we have to consider these 3 forces for this equation. And these 3 forces are acting towards right, so we will consider their sign positive. It means equation will be 900 plus Rex equal to 0. So from here we will get our first answer, that is Rex equal to minus 1800 Newton. So we have concluded that Rex has a magnitude of 1800 Newton, but it has a negative sign. That means the assumption which we made for the direction of Rex at the start is not correct. Actually, it is acting towards left. So this is the correct direction of Rex. Now after this we will apply the second equation, that is summation Fy equal to 0. So let us see how many forces are acting in Y direction. There are 2 forces, Rey and Rfy. It means our equation will be Rey plus Rfy equal to 0 because both are acting in our direction, so we have to assume their sign positive. And this is a single equation. In this equation we have 2 unknowns, so we cannot solve it. So let us call this equation as equation number 1 for time being. Now let us apply the third equation, that is a moment equation. So let us take moment about joint E. Why we are taking moment at joint E? Because at joint E 2 forces are acting. So if we will take moment at joint E, then moments because of these 2 forces about that joint will be 0 because their perpendicular distance from that joint is 0. So it means we will directly get rid of these 2 unknowns. So our equation will be simple. So we will left with only 3 forces for which we have to calculate the moment about this joint, that is joint E. So that is why we are taking moment about joint E. So let us first consider moment because of 900 Newton about joint E. For 900 Newton force acting at joint A, this is the line of action and this is the moment center. So we will drop a perpendicular from moment center onto the line of action of 900 Newton force acting at joint A. Then that perpendicular distance will be equal to 4.5 meters. So the magnitude of the moment generated by 900 Newton force acting at joint A about joint E will be equal to 900 into 4.5. Now let us see its nature also. It will generate a clockwise moment, so its nature is clockwise and we will consider its sign negative. It means final answer for the moment of 900 Newton force acting at joint A about joint E will be equal to minus 900 into 4.5. If you will see carefully, then you will find that 900 Newton force acting at joint C will also have a clockwise moment. So moment because of this force will also be negative and its magnitude will be 900 multiplied by this distance 2.25 meters. So moment because of this force about joint T will be equal to minus 900 into 2.25. Now let us discuss the moment generated by RFY about joint T. This reaction will generate anti-clockwise moment, so we will consider it as positive and that will be equal to RFY into 3 because 3 is the perpendicular distance between the line of action of this force and the moment center. So our final equation will be minus 900 into 4.5 minus 900 into 2.25 plus RFY into 3 equal to 0. So from here we will get the value of RFY. And you can see this is a positive value. That means whatever direction we have assumed at the start for RFY, that direction is correct. So it is acting in upward direction. Now we have found REX, we have found RFY, now it is time to find REY. So for that we will say put value of RFY in equation 1. Then you will get value of REY and that is a negative value. So negative sign over here tells us that the direction which we considered for REY at the start is not correct. Actually, it is acting in downward direction. So we have found the values of these three reactions at these two supports. Now in the next step what we will do, we will label their correct directions and their magnitudes. So reaction at F is acting in upward direction, so we will not change it because we got positive sign when we were calculating its value, so we will just label its magnitude as 2025. But at joint T we have to label the normal reaction in downward direction and its magnitude is 2025, and we have to label the reaction which was acting along the surface towards left because we got negative values for these two reactions in the previous calculations. So the magnitude of this reaction is 1800. After this what we will do, we will find the forces in all the members of this truss. And we know if we have to find the forces in these members, we have to start with the equilibrium of a particular joint. And we have to start with that joint only at which maximum unknowns are 2. Now if you will see joint E, at joint E there are only 2 members connected to joint E, and it means we have only 2 unknowns at joint E and we can start with joint E. So we will say equilibrium of joint E. For that we will apply two equations, summation fx equal to 0 and summation fy equal to 0, but before that we have to first draw the free body of joint E. So let us draw free body of joint E. So for that first of all we have to label the joint on paper. So let us call that joint as E, and then we will see how many members are connected to that joint. So to joint E, 2 members are connected, one is along horizontal direction and second is in vertical direction. So let us show these 2 members in the free body. So we have drawn one horizontal line at joint E and second line is at 90 degrees to joint E. So we have labeled two members, member EF and member EC in this free body. And we know in these two members the forces are unknown to us. So if forces are unknown to us, then we consider their nature as tensile nature. It means in these two members we will label the direction of the forces away from the joint. So this is member EF. So we have labeled the force in member EF away from the joint, means tensile nature. So this is FEF. Similarly, in member EC, we will label the direction away from the joint, that is tensile nature, FEC. Now after this we will see, is there any external force acting at joint E? No, there is no external force acting at joint E. Then we will see, are there reactions acting at joint E? Yes, there are two reactions acting at joint E. So the first reaction is acting in horizontal direction towards left. Its magnitude is 1800. And second reaction is acting in downward direction. Its magnitude is 2025. After that we will see, is there any inclined force in the free body? No. In this free body there is no inclined force. It means we are ready with the free body of joint E. Now we can apply those equations of equilibrium. So let us start with the first equation, that is summation Fx is equal to 0. So how many forces are there which are acting in x direction in this free body? There are two, FEF and 1800. FEF is acting towards right, so we will consider this as positive. 1800 is acting towards left, we will consider this as negative. So final equation will be FEF minus 1800 is equal to 0. So from here we will get the value of FEF as 1800 newtons. So we got positive sign over here. The meaning of positive sign is that the assumption made by us for FEF at the start, that is tensile nature, is correct. So next to the magnitude we will label its nature as tensile by writing letter T. After this we will apply the second equation, that is summation Fy equal to 0. Let us see how many forces are acting in this free body in y direction. So there are two forces, FEC and 2025. FEC is acting in our direction, we will consider this as positive. And this force 2025 is acting in downward direction, so we have to consider this as negative. It means our equation will be FEC minus 2025 equal to 0. So from here we will get the value of FEC. And this is also a positive value. So that means the direction of FEC considered by us at the start, that is tensile nature, that is away from the joint, is correct. So next to its magnitude we will write letter T. So from the free body of joint T we have found two forces. The first one is FEF, it is acting in member EF and it is of tensile nature, it means it is acting away from joint T. And second force is FEC, it is acting in member EC and it is also acting away from joint because its nature is also tensile. So we have found forces in member EF and EC. Now next step is we have to find the forces in other members of the truss. So for that we have to pick the next immediate joint. Now you can see in this truss there are so many joints, A, B, C, D, F, E. We have solved joint T. So after that we have to pick next immediate joint. So next immediate joint to E is joint F or joint C. So out of these two joints, joint C and joint F, we can start with that joint only at which maximum unknowns are 2. So let us first see joint C. At joint C, 4 members are connected. But in this member we have found the force. It means at joint C still we have 3 unknowns. So it means we cannot start with joint C. Let us see joint F. At joint F, 3 members are connected, but this member is known to us because we have found the force in this member. It means at joint F there are only 2 unknowns. So we can start with joint F. It means after joint E we will discuss about the equilibrium of joint F. So next step is we will say equilibrium of joint F. So that means first of all we have to draw the free body of joint F. So let us draw the free body of joint F. So first step is label that joint on the paper. After that, you should see how many members are connected to that joint. So there are 3 members connected to that joint, that is F. One member is in horizontal direction, one is in vertical direction, and third one is at some angle to the horizontal. So let us show these 3 members in this free body first. So we have drawn horizontal member EF, inclined member CF or FC, then the vertical member FD. Now after this we will label the direction of forces in these 3 members, and we will start with known member first. So out of these 3 members, this is a known member for us, because for this member we have already found its force, that is 1800 Newton, which is a tensile force. And we know that this force is acting in member EF and it is acting towards joint F. It means joint F will provide equal and opposite reaction, and that reaction will be considered as active force in the free body of joint F. So see, in the free body of joint F, we have considered this direction for the force EF. We have considered towards left. So let us label that value, that is 1800. Now the 2 members are unknown members to us, so in these 2 members we will consider their direction away from the joint. So this is a member named as FC, so we have considered its direction away from the joint, so we have labeled the force FFC. Name of this member is FD, so in this member we have labeled the direction away from the joint, so this is FFD. Now after this we will see, is there any external force acting at joint F? There is no external force acting at joint F. Then we will see, is there any reaction acting at joint F? Yes, there is one reaction acting at joint F in our direction, and the magnitude is 2025. So let us show this reaction in the free body of joint F. Now after this we will see, is there any inclined force in the free body of joint F? Yes, there is one inclined force, FFC. So next step is we should resolve that force into its components. So the origin of this force is over here. So from this point we will draw 2 lines, one in horizontal direction and the other one will be in vertical direction. So these 2 are the components of this force FFC. So let us label the directions of these 2 components. For that we have to see the direction of force first. Now the force is acting away from the joint. So in these 2 components also we have to consider direction away from the joint. So over here also direction will be away from the joint. Now let us find the magnitudes of these 2 components. So for that, first of all we have to find the angle of this particular force with any of these 2 components. So let us find its angle with the horizontal component, and let us say that angle is theta. So first of all we have to find the value of theta. So let us see, where is this theta in this truss. So this theta is over here. So in order to find this theta we have to consider this right angle triangle CEF. So we will say, in triangle CEF, perpendicular upon base is equal to tan theta. So that means 2.25 divided by 3 is equal to tan theta. Or we can say theta is equal to tan inverse of 2.25 divided by 3. So from here we will get the value of theta as 36.86. So we have found the value of theta, and this theta is the angle between the force and the horizontal component. It means this is a cos component and other is a sine component. So let us label these magnitudes. So we'll call this as FFC cos 36.86 and this will be called as FFC sin 36.86. So now we are ready with the free body of joint F. So after this we will apply equations of equilibrium. So let us first apply summation Fx is equal to 0. So how many forces are acting in x direction in this free body? There are 2 forces, FEF and FFC cos 36.86. Both are acting towards left, so we have to consider these 2 negative. It means final equation will be minus 1800 minus FFC cos 36.86. So from here we will get the value of FFC, and we got negative value. So negative sign over here tells us that FFC is not a tensile force, because at the start we assumed its nature as tensile away from the joint, but we got negative sign, so it means it is not tensile force, it is a compressive force and it is acting towards joint F. So next to its magnitude we have written letter C, that tells us that it is a compressive force. After that we will apply the second equation, that is summation Fy equal to 0. So for that we have to see how many forces are there which are acting in vertical direction in this free body. So there are three forces. 2025 acting in upward direction, we will take this as positive. FFD is also positive, acting in upward direction. Then FFC sine 36.86, it is also acting in upward direction, so this is also positive. So final equation will be 2025 plus FFD plus FFC sine 36.86. And we have already found the value of FFC. Let us put that value, which is minus 2250, in this equation, and from that equation we will get value of FFD, and we got negative value over here. So negative sign tells us that FFD is also a compressive force, because at the start we considered its nature tensile, that is away from the joint, but we got negative sign, so it means FFD is also a compressive force and it is acting towards joint F. So from these two equations we have found two forces. The first one is FFC, it is acting in member FC and it is a compressive force, so we have shown its direction towards the joint. Second force is FFD, it is acting in member FD and it is also a compressive force, so we have shown its direction towards the joint. Now after this we have to pick the next immediate joint. So we have solved joint F. So to joint F, the next immediate joints are joint D and joint C. So let us see with which joint we can start. Let us first observe joint D. To joint D, four members are connected, and this member is a known member to us, but still there are three unknown members. It means at joint D there are three unknowns. It means we cannot start with joint D. So let us observe the next immediate joint, that is joint C. To joint C there are four members connected, and these two members are known members now. It means at joint C there are only two unknowns, so we can start with joint C. Okay, so in the next step we will say equilibrium of joint C. It means what is the next step? Next step is we should draw the free body of joint C. So let us draw a free body of joint C. So let us label joint C on paper. Then we will see how many members are connected to joint C. There are four members. Two are in vertical direction, one is in horizontal direction, and fourth one is at some angle to horizontal. So let us show these four members first. So we have shown the horizontal member CD, then vertical member CA, then third member which is also vertical CE, and the fourth member is at some angle to the horizontal direction and the name of that is FC. Now let us label the direction of forces in these four members, and we start with known member first. These two are known members to us, so let us start with this member. The name of this member is EC, and we have already found its force. It is tensile in nature and it is acting towards joint C, and joint C will offer equal and opposite reaction. That reaction will act as active force in the free body of joint C. So see, we have considered its direction away from the joint, away from the joint. Now let us observe the next known member, that is FC. In member FC we have found that force is compressive force. It is acting away from joint C and towards joint F. So it is acting away from joint C, so joint C will offer equal and opposite reaction. So that means in the free body of joint C, we will consider direction towards joint C. Look over here. Now these two members are unknown members. So for unknown members, we consider direction away from the joint, that is tensile nature. So this is member CD. So we have labeled its direction away from joint, and the force is labeled as FCD. And this member is CA, and in this member also we have considered the direction of force away from the joint, and we have labeled it as FCA. Now after this we will see, is there any external load acting at joint C? Yes, there is one external force of 900 Newton acting at joint C in horizontal direction towards right. So let us show that force over here. Then after that we will see, is there any reaction acting at joint C? No, there is no reaction acting at joint C. Then we will see, is there any inclined force acting in the free body? Yes, there is one inclined force acting in this free body. So next step is we should resolve that force into its components. So this is the origin of this force. So from the origin we will draw two lines, one in horizontal direction and one in vertical direction. Now in these two members we will label the direction. For that we have to see the direction of the force first. So force is acting towards origin. So in these two members also we will consider their direction towards origin. So in this member also towards origin. Now after that we will find the magnitudes of these two components. For that, first of all, let us locate the angle of this force with any of these two components. So let us locate its angle with horizontal component. Let us call that angle as theta. So let us first find where is this theta in the truss. This theta is over here, and this theta or this angle is equal to this angle. These are alternate angles, and this angle we have already found. This is equal to 36.86. So this is also 36.86. So it means this component will be a cos component and this is a sine component. So we will label it as 2250 cos 36.86. So this will be 2250 sine 36.86. So we are ready with the free body of joint C. Now we'll apply equations of equilibrium. So let us start with the first equation, that is summation fx is equal to 0. So let us see how many forces are there in the free body which are acting in x direction. So first force is 900 Newton. It is acting towards right, so this is positive. Next is FCD. It is acting towards right, so we have to consider this also positive. Now this component is acting towards left, so we have to consider this as negative force. It means final equation will be FCD minus 2250 cos 36.86 plus 900 is equal to 0. So from here we will get value of FCD, and we got positive value. That means the direction which we assumed for FCD at the start is correct. It means it is a tensile force. Now after that we will apply the second equation, that is summation Fy equal to 0. Now how many forces are acting in this free body in y direction? There are three forces. This is component of 2250 and it is acting in upward direction, so we will consider this as positive. Then we have 2025, another force acting in downward direction, we will consider this as negative. Then FCA acting in upward direction will be considered as positive. So final equation will be 2250 sine 36.86 minus 2025 plus FCA equal to 0. So from here we will get value of FCA, and we got positive value. That means the direction considered by us for FCA is also correct, so it is a tensile force. Now from this free body we have found two forces. One is labeled as FCD and we have found it is a tensile force acting away from the joint. The second one is FCA acting in member CA and it is also a tensile force acting away from the joint. Now after that we have to pick next immediate joint. Now to see, there are two next immediate joints, joint D and joint A. And for both the joints, maximum unknowns are 2 only. So we can pick any joint. So let us pick joint D. So we'll say equilibrium of joint D. So for that we have to first draw the free body of joint D. So we'll mark the joint on the paper. Then we will see how many members are connected to that joint. So to joint D there are 4 members. 1, 2, 3, 4. Let us show these 4 members. So one is member CD, which is a horizontal member. Then we have vertical member DB. Then another vertical member DF. Then we have member DA at some angle to the horizontal. Our next step is label the forces in these 4 members and start with known members first. So let us start with this member CD. And in this member we have found that force is tensile and it is acting towards D. So D will offer equal and opposite reaction. That reaction will be considered in the free body of joint D. So we have labeled it away from joint D. Then we will discuss about the next known member, that is DF. And in DF we have found that this force is acting away from joint D, so D will give equal and opposite reaction, that is towards joint D. So let us label that reaction over here in the free body of joint D. Then these two members are unknown to us. So in these two members we will consider their direction away from the joint, means tensile nature. So this is member DA, so we have labeled the force in this member as FDA, away from the joint. This is member DB, so we have labeled its force FDB, away from the joint. Now after that we will see, is there any external force acting at joint D? No, there is no external force. Then we will see, is there any reaction acting at joint D? No, there is no reaction at all at joint D. Then we will see, is there any inclined force in the free body? Yes, there is one inclined force. So we have to resolve that force into its components in the next step. So this is the origin of that force. So from this origin we will start two lines, one in vertical direction and second in horizontal direction. So these two are representing the components of this force. Now we have to label the direction of these components. For that we have to see the direction of force first. Direction of force is away from joint. So in these two components also we have to label away from joint. Away from joint. Now we have to find the magnitude of these two components. So for that we have to first find the angle of this force with any of these two components. So let us find its angle with the horizontal component and let us label that angle as theta. So where is this theta? This theta is over here. And you can see this is also same angle. So it is equal to 36.86. Now we have considered the angle of this force with this component. So this is a cos component. This will be a sine component. It means we will label this as FDA cos 36.86. This will be FDA sine 36.86. Now we are ready with the free body of joint D. So let us apply the first equation, that is summation fx is equal to 0. So how many forces are there which are acting in x direction? There are two forces, FCD and the component of force FDA. Both are acting towards left, so we have to consider these two negative. So final equation will be minus FDA cos 36.86 minus 900 is equal to 0 because value of FCD is 900. So from here we will get our answer for the force FDA, which is acting in member DA. And we got negative sign. That means DA is a compressive force because initially we assumed DA as tensile force away from the joint, but we got negative sign, so we have to say it is a compressive force. Now we have to find forces in other members DB and member AB. But over here you can see that these two members are zero force members because these two are at 90 degrees to each other and there is no force acting at joint B where these two are connected. So we can say directly that member DB and member AB are zero force members. So there is no need of applying the next equation even. Then we will directly write FDB and FAB are zero force members. And if you will apply the next equation as summation Fy equal to 0, then also you will get the value of FDB as 0. So you have two options. Either you can apply the next equation summation Fy equal to 0, or you can simply write that member DB and member AB are zero force members because they are connected at 90 degrees to each other, and the joint at which these two are connected has no other force. So these are zero force members. So let us label this force, that is FDA. So we have found it is a compressive force. So we have to show this force acting towards joint D. And there is no force in member DB and AB. These are zero force members. So I hope the answer of this particular question is clear to you. Thank you very much.